My dear students, in this question, a particle starts from origin, accelerates for t naught second, and then decelerates with same magnitude of acceleration till 2t naught. Okay, if we draw the diagram regarding this, suppose at t equal to 0, particle is here, and its initial velocity is 0, u equal to 0, u equal to 0. Now its acceleration is constant, then speed of the particle increases till t equal to t naught. Here time is t equal to t naught. From t equal to 0 to t equal to t naught, speed of the particle will increase. Suppose at t equal to t naught, speed becomes v, and displacement of the particle from t equal to 0 to t equal to t naught is s1. This displacement is s1. Again, after t equal to t naught, particle gets retarded. That means acceleration will be opposite to the direction of velocity, and magnitude of this deceleration is same as magnitude of acceleration. Now this acceleration is opposite to the velocity. That means now speed will decrease and particle will move in the direction of velocity. Particle will move further, x coordinate again increases, and we are considering motion up to t equal to 2t naught. If you have analyzed this situation, then we can give the answer directly without any other calculation, because we know that if acceleration of the particle is constant from t equal to 0 to t equal to t naught, since acceleration of the particle is constant, then position time graph, that means xt graph, will be concave upward. So from t equal to 0 to t equal to t naught, since acceleration is positive, then xt graph will be like this, and from t equal to t naught to t equal to 2t naught, acceleration is negative, then in that time interval, position time graph or xt graph will be like this, concave downward. Now we have to check in all four options. In first option, this is concave upward, this is concave upward, this is concave from t equal to 0 to t equal to t naught. Again this portion is concave upward. Here also from t equal to 0 to t equal to t naught, graph is concave upward. In all four options, from t equal to 0 to t equal to t naught, xt graph is concave upward. Then we cannot conclude from here. Then check further, from t equal to t naught to t equal to 2t naught, graph should be concave downward. In first option, graph is like this. In first option, graph is like this. So this is the part of concave upward graph. Then this is incorrect. Again in fourth option, from t equal to t naught to t equal to 2t naught, graph is again concave upward. Then this is also incorrect. Now we have to check for option 2 and option 3. In option 2, this graph is concave downward. This portion is concave downward. In graph 3 also, this portion is like this. This is also the portion of concave downward. Then in graph 3, this is also part of concave downward graph. In option second, this is also the part of concave downward graph. But in this case, in third option, x coordinate is again increasing. From t equal to 0 to t equal to t naught, x coordinate of the particle increases. According to this graph, from t equal to t naught to t equal to 2t naught, again x coordinate is increasing. According to this situation, from t equal to 0 to t equal to t naught, x coordinate will increase. Again velocity of the particle will decrease from t equal to t naught to t equal to t naught, but further of t naught, x coordinate also increase. From t equal to t naught onwards, x coordinate of the particle is still increasing. This graph shows that x coordinate is increasing, but this graph shows that x coordinate is decreasing beyond t equal to t naught. Then this option will be incorrect. Hence final option is 3. Final option is 3. If you want to check the other data from exam point of view, this is sufficient. Just tick and move on. Okay, for next question. But we have to learn the things here. Then to learn these things for learning purpose, if we check this data at t equal to t naught, x coordinate is half a into t naught square. At t equal to 2t naught, x coordinate will be a into t naught square. How this come? Let's check. At t equal to 0, speed is 0. At t equal to t naught, velocity is v. From t equal to 0 to t equal to t naught, first use first equation of motion, v equal to u plus at. At this point, u is 0, acceleration is a, time of motion is t naught. Then this velocity is v equal to a into t naught. Again use first equation of motion from t equal to t naught to t equal to 2t naught. According to first equation, again v equal to u plus at. From t equal to t naught to 2t naught, if final velocity is v dash, here we consider that velocity of the particle is v dash, then v dash equal to, here initial velocity a into t naught, acceleration opposite, then negative sign minus a into, from here to here time of motion is t naught, this is t naught, a t naught minus a t naught equal to 0. That means at this point velocity of the particle becomes 0. Velocity of the particle becomes 0. At t equal to 2t naught, velocity is 0. According to this graph, at t equal to 2t naught, slope is 0, then velocity is 0. But according to this graph, at t equal to 2t naught, slope is non-zero. That means this graph shows that at t equal to 2t naught, velocity is not 0. Then this graph is not possible. Final answer is this. Again, if you check the displacement from t equal to 0 to t equal to t naught, use second equation of motion and get the displacement S1. Then if you want to find out the value of S1, then S1 equal to ut plus half at square, ut plus half at square. At t equal, this equation is used from t equal to 0 to t equal to t naught. We know that at t equal to 0, initial velocity is 0 plus half, acceleration is a into t naught square. Then S1 is half a into t naught square. Again use the second equation from t equal to t naught to t equal to 2t naught. We get the displacement S2. This will be equal to ut plus half at square. At t equal to 2t t naught, this will be value of u. This displacement is S2. From t equal to t naught to 2t naught, we consider the displacement S2. Then this will be given by ut. Value of u is a into t naught. Value of u is a into t naught into time of motion is t naught plus होगा half. Acceleration will be negative minus a and time of motion is t naught. Then t naught square. On solving this, we get a t naught square minus half into a into t naught square, and this value will be half into a into t naught square. Then S1 and S2 both are same. So at t equal to t naught, S1 is half a into t naught square, the next coordinate will be half a into t naught square, and at t equal to 2t naught, final x coordinate is, this is x equal to 0, that means origin. At t equal to t naught, final x coordinate equal to S1 plus S2. Then S1 plus S2 will be equal to a into t naught square. This graph represents this value, hence final answer is 3. I hope all things are cleared. Thank you.